distribution of total number of stores is stores for TS plus stores for CS, AC will build. Now, I mean, as far as TS is concerned, it can be having 0, 1, 2, or 3 stores. As far as CS is, it can be having 0, 1, or 2 stores. So the total number of stores could be anywhere from 0 to 5. 3 for TS and 2 for CS. That's the maximum number of stores AC can build. And so let's solve it, and I'm going to show you the solution over here. You have this. So over here, probability distribution for TS. Here is probability distribution for CS. Okay. Now, the outcomes could be 0, 1, and 2, 0, 1, 2, or 3. So what's the probability that there will be 0 store for TS and 0 store for CS? So it is 0.3 times 0.1. So 0.30 times 0.1, 0.10 is 0.03. So that's how you're going to be finding out joint probabilities. Okay, you're going to take this one multiplied by this one multiplied by that, and so on. Okay, when the outcomes are independent, then how do you get joint probability? Just take probability of each outcome and multiply. So that's what we did. We made a table of joint probabilities. So this is the table of joint probability. Now, question is, make probability distribution of total number of stores for TS plus stores for CS, AC will build. Total number of stores could be anywhere from 0 to 5. No store for CS, no store for TS is 0. Or 3 stores for TS and 2 stores for CS is 5. So the number of stores could be anywhere from 0 to 5. So 0 and 0 is 0.03. So that's over here. The next one is 1. So 1 store for CS and 0 store for TS. So that is 0.05. Now 1 store for TS and 0 store for CS is 0.09. So there are 2 ways that you can have 1 store in total. And the probability for that is 0.09 plus 0.05. Add these 2 and the answer is 0.4. You guys are okay with that? So this column, which is giving you different values, and this column, which is giving you probabilities, when you take these 2 together, you have probability distribution. So probability distribution, total number of stores is this and that. Now, the next question is, what will be the probability distribution of total profit AC can earn a profit of $100,000 from each store it builds? Okay. So the store is going to be building is 0, 1, 2, 3, 4, 5. Okay, each store will give profit $100,000. So the profit is going to be 0, 100, 200, 300, 400, 500. And this is the probability distribution. Now the next question is, determine the expected value and standard deviation of total profit. Very simple, okay? This times this, this times this, this times this. Okay. You find those products, add them, and the answer is $260,000 is the expected profit. Now, what is the variance and standard deviation? I mean, you can use the typical formula, which is this over here. I wrote it down with pencil, okay? So, 0 minus 260 is squared multiplied with the respective probability. 100 minus 260 is squared multiplied with the respective probability. You can either do that or you can do it this very simply. So you already have expected total profit, but next thing you're going to do is you are going to find out expected value of TP squared. So just square each profit value and multiply with the probability, and you have this graph. Now you're not finding out any deviations. You're not separating this from that. You're not doing that. You are just creating another column. So when you do that, you have this, and the formula is simply expected value of TP square minus expected value of TP outside bracket square. And the answer is 114,020. So that is going to be your standard deviation. The mean expected value is $260,000 with a standard deviation of $114,020. You guys are okay with that? Okay. We are going to be looking at discrete probability distribution, and we are going to be looking at continuous probability distribution. Okay. So we're going to go over it very quickly, okay? Now, here is an example of discrete random variable. Number of TVs sold at a store in one day. I mean, it's something which can count. Okay. So, number of TVs are sold in a store in one day, or number of students in the class. Okay, that is discrete. Okay. Here are examples given for a discrete random variable. Okay. Now, family size, number of dependents reported on tax return. Okay, 1, 2, 3, 4, 5. Okay, and own dog or a cat. Okay, how many dogs, how many cats you own. Distance from home to store on a highway. Now, I mean, even like rounded number is 1 kilometer. So let's say the distance from home to highway is 1 to 2 kilometers. But there are infinite, I mean, depending on how precise you are, there are infinite values between 1 and 2 kilometers. 1.00000, and you go as many times, I mean, you go many, many times, you get 1. That is one answer. So there could be infinite possibilities. So as far as distance is concerned, it is a continuous random variable. Weight, is it continuous or discrete? Value, weigh yourself, and it tells you 120 pounds. Is it really 120 pounds exactly? It might be 120.000000365. And so, as far as height is concerned, weight is concerned, distance is concerned, those are continuous random variables. Now, probability distribution for discrete random variable. Okay. Yeah. So, number of units sold in a day, anywhere from 0 to 4. Okay. How many days you sold 0 unit, how many days you sold 1 unit, 2 units, 3 units, and 4 units. I mean, here are the number of days, and here are total number of days. If I ask you a question, what's the probability that you sold at least 3 stereo, at least 3 TV sets? What's the answer? Answer is right in front of you. What's the probability of selling at least 3 TV sets? 0.05 plus 0.10. What's the probability of not selling more than 2 TV sets? Not selling more than 2. 0. Not selling more than 2 TV sets. 0.85. So not more than 2 means 0 or 2. Yeah. So 0.40 plus 0.25 plus 0.20. Okay. I mean, you can show it by this chart over here. How do you find expected value? I mean, you just take, I mean, as far as discrete random variable is concerned, how do you find expected value? Tell me, how do you find expected value over here? 0 times 0.40, 1 times 0.25, 2 times 0.2. We just did that, right? In the other example. Okay, so that's how you find expected value. Okay. And same thing, okay, how do you find variance? We just did that. So here is the calculation for expected value, okay, 0 times 0.40, 1 times 0.25, and so on. And here is the calculation for variance, okay. From each value, you subtract the mean value and then multiply with the respective probability. So from each value, 0, subtract the mean value and multiply with the respective probability. So 0 minus mean value is squared, and here is the respective probability, and this is you have add all these. 1.660 is variance, and the square root of that is standard deviation. Okay. Now, if you know some kind of pattern as far as your distribution is concerned, that will help you in figuring out probabilities very easily. So, if you know that this distribution has these particular characteristics, so you can find probabilities very easily. So one of the distribution is binomial distribution. Now, what is binomial distribution? In case of binomial distribution, there are only 2 outcomes. There are only 2 outcomes. Let's say you are interested in blue cars, blue color. So the 2 outcomes are cars which are blue color and cars which are not blue color. You are interested in blue cars, so there are 2 outcomes: cars which are blue colors and cars which are not blue colors. In binomial distribution, there are only 2 outcomes. Now, in binomial distribution, probability of success remains constant. So, let's say if all the cars in Toronto, 10% are blue. If you pick a car at random, probability is blue is 10%. If you pick another car at random, probability is blue is 10%. Let's say like all these students, or all the population of the whole world, okay, 40% are males, which means 60% are not males. There are only 2 outcomes. Okay, 40% are males, 60% are not males. If you pick a person at random, what's the probability that person is a male? And if you pick the second person, 20%, because population is so huge. Okay, it's millions. Okay, population is so huge. Now, look at another way. So here I'm talking about a huge population. 40% of the students in this class are male, which means 60% are not males. If I pick a student at random, probability that this person is male is 40%. If I put this student back into the class, so let's say I pick one student, 40% probability is that this person is male, and then I ask this person to sit down again. What's the probability that when I pick this student second time, it's a male? 20%. This is called sampling with replacement, because the number of people are not changing, and number of males are not changing. So I picked a person, put the person back. Again, same number of students, and 40% of them are male. Okay. So population is finite over here. Remember that. It's not infinite population. It's finite. It's only 60, 70 students. Okay. But if I keep putting this student back, okay, probability is not going to change. On the other hand, so I'm not just doing binomial distribution over here. I'm talking about things which are coming later also. So in case of binomial, so here is male, not male. So 0.40, 0.60, and then male, 40, 0.60. So either population is infinite or it's with replacement. Infinite or with replacement. So the probability of success is not changing, which means probability of failure is also not changing. So probability of male is 40%, probability of not male is 60%. So they are not going to change. Now, so there are total students are 100. Same thing, right? 40 over 100. So what's the probability that a person is a male is 40 over 100, and this is 60 over 100, right? I picked one person. What's the probability that this person is a male? 40 over 100 and 60 over 100. This is finite population and without replacement. Without replacement. What does it mean? It means that when I took out one person, that person is out. So now over here I have 39 over 99, and over here I have 60 over 99. Over here I have 39, no sorry. Over here I have 40 over 99, and this is 59 over 9. So what you see now, probability is changing. And this is called hypergeometric distribution. When the probabilities are not constant, okay, they're changing, so that is hypergeometric. Now the thing is this, if we are dealing with the population of Toronto, 5 million people, and I pick, and of those 5 million, 40% are male and the remaining are not male, okay? So 5 million people in Toronto, and of course, its sampling is without, I'm picking the people and not putting them back, it's without replacement. So the distribution is hypergeometric because probabilities are changing. But can I just approximate with binomial? Like over here, I have, let's say this is, keep the numbers there. Here is 40 million over 100 million. This is 3,999,000 and 99999. Will it make any difference when the values are so large? It doesn't make any difference. Okay. So when the numbers are huge, okay, then we don't need to make any distinction between binomial and hypergeometric. Because I mean, 4 million or 40 million over 100 million, or just one number less over here and one number less over here, doesn't make any difference. You guys are okay with that? So, so this is what we just saw about binomial distribution, okay? And probability of success remain constant, which is probability of failure is also remaining constant. It doesn't change from trial to trial, okay? Now, tell me one thing. When you toss a coin, and I asked you probably in the last class, there are two outcomes head and tail. There are two outcomes head and tail. Are they dependent or independent? Sorry, what? Dependent? Dependent? Okay. So if you toss a coin, probability that you will get head depends upon probability that you are not getting tail. I mean, you will get head only if you don't get tail. So they are dependent. Now, toss a coin, you got whatever. Toss a coin second time, you got whatever. Probability from one trial to another trial, or the outcome on one trial, outcome on the next trial, are they dependent or independent? If I get a head on the first trial, does it depend on getting head on the second trial? Or if I get a head on the first trial, on the second trial, occurrence of head, does it depend on the first trial? No, there is independence. Okay, so from trial to trial, there is independence. So that's what binomial distribution is. Now, I mean, you can solve binomial problem in many different ways. You can make a tree diagram, or you can use a formula. Okay. So over here, in how many different ways? Let's just come over here. So here I'm defining a few terms over here. X is equal to number of successes, P is equal to probability of success on one trial, N is number of trials, and probability of X success in N trials. If I pick 5 students, what's the probability that 2 are going to do CP? So small n is 5 and X is 2. So if I pick 5 students at random, what's the probability that 2 are going to do CP? So over here, in how many different ways you can have 2 students who are doing CP? Let's look at this question. And we are going to be solving it. I think we are solving it both by tree and by tree and by formula. EMA's electronic is concerned about a lower retention rate for its employees. In recent years, management has seen a turnover of 10% of hourly employee annually. Thus, for any hourly employee chosen at random, management estimates a probability of 0.1 that the person will not be with the company next year. Okay. Choosing 3 hourly employees at random, what is the probability that one of them will leave the company this year? Now, what's the probability that employee will leave a company in a year? Is 10%. Employee will not leave a company in a year is 90%. So here is, so the question is, let's just look at the question. Choosing 3 hourly employees at random, what is the probability that one of them will leave the company this year? So if you select 3 employees, what is the probability that exactly one of them will leave the company in a year? So I'm going to be looking at it first, but from this using this tree diagram. Okay. So leave the company, do not leave the company. 0.1, 0.9. One employee is leaving the company. Does his or her leaving the company depend upon another employee leaving the company? Answer is no. Okay. So probability of leaving the company will remain constant. Now, leaving the company doesn't sound positive, but the thing over here is the outcome which you are interested in, you call it a success. So the probability of success is 0.1. Okay. So 0.1 and 0.9. over here. So first employee leave the company, 0.1, do not leave the company, 0.9. Second employee leave the company, 0.1, do not leave the company, 0.9, leave the company, 0.1, do not leave the company, 0.9. Third employee leave the company, 0.1, not leave the company, 0.9, leave the company, 0.1, 0.9. Okay. So these are all different possibilities we have. Now I'm interested in that exactly one employee will leave the company. Okay. Exactly one employee will leave the company. Over here is you have 3 employees and all 3 left the company. Your small n, your sample size 3, and all 3 of them left. X equal to 3, and the answer is 0.001. So if I ask you a question, what is the probability that if you have 3 employees, all 3 employees will leave the company in a year? Answer is 0.001. That's the only way. Okay. Now over here, leave the company, do not leave the company. So over here, 2 employees out of 3 are leaving the company. Leave the company, stay, leave the company. Here also, 2 employees are leaving the company. Leave the company, stay, and stay. So here, 1 employee is leaving the company. Stay, leave. Here, 2 employees are leaving the company. Stay, leave, and stay. Here is 1 employee is leaving the company. Stay, and leave. So 1 employee is leaving the company. Stay, and 0 employees leaving the company. In how many different ways you have 3 employees leaving the company? Answer is only 1 way. In how many different ways you have 0 employee leaving the company? Answer is only 1 way. All 3 are staying. In how many different ways you have exactly 1 employee leaving the company? This, and this. First one left, other 2 didn't leave. First one left, other 2 didn't leave the company. First one stayed, second one left, third one stayed. First one stayed, second one stayed, third one left. So these are 3 ways that you can have 1 employee leaving the company, and this is the answer. Okay. Now, how many different ways? There could be 2 employees leaving the company, and the answer is 0.009, 0.009, 0.009. Now, so here we are talking about combination. So now you can do this by making a tree diagram, but it is too time consuming. What if there are 4 employees? What if there are 4 employees, and I want you to tell me what's the probability that exactly 2 will leave? So the table will keep becoming bigger and bigger. What you can do is you can use the formula. So here is the formula to calculate binomial probabilities for 0, 1, 2, 3, 4, whatever number of implies. So this is your sample size. This is the number of success in the sample, and these are the number of failures. And the answer is, in how many different ways you can have 1 employee leaving the company. So that is over here. And the answer is 0.24. You guys are okay with that? Now, like any distribution, normal distribution also has a mean and a standard deviation. Each distribution is defined by its mean and standard deviation. Same thing in normal distribution. Normal distribution has a mean and standard deviation. How do you find out the mean? Mean is simply sample size times probability of success. Okay, n times p. And how about the variance? It is sample size times probability of success times probability of failure. Okay. So variance is np, 1 minus p. 1 minus p is what? 1 minus minus P is probability of failure. So if P is probability of male, then 1 minus P is probability of not male. Okay. So here is the expected value, here is the variance, and standard deviation is simply the square root of variance. So binomial distribution question could be like this. Sample size 3, if I pick a sample of 3, what's the probability that at less than, not more than 2 employees will leave the company? This is less than equal to 2. When the probability employees will leave the company is 0.10. Now over here, I'm not asking you for exactly 2 employees are leaving the company. I'm asking you to give me the probability that no employee, 1 employee, or 2 employees are going to leave the company. So just imagine, okay, if you're making the tree diagram, sorry, if you're making the, if you're using the formula, if you're using the formula, you have to solve this for 0, you have to solve this for 1, you have to solve this for 2. On the other hand, if you are using the tree over here, you already have the answer for 0, and 1 can happen in these 3 different ways. So add this, this, and this probability plus this, and also add these probabilities for 2. Or the easier way is, if you have this tree diagram, what's the probability that less than or equal to 2 employees will leave the company? What's the easier way?
Calculate the probability above and then 1 minus.
Okay, so thanks a lot. Okay, so the outcomes are only these outcomes: 0, 1, 2, and 3. So in this question, the only thing which is left out is 3. So what you do from 1, you just subtract the probability of 3, which is 0.001. Let's do that. Now, you can use also binomial tables. Okay. Where is the table? You can also use the binomial table. So over here, you have the probabilities, and here you have the sample size, and here we have the successes you are looking for, number of successes you are looking for. So you can use this table. Now, you are interested in exactly 1 employee leaving the company. Answer is, like, probability that employee is going to leave the company is 10%. Okay, and we are going to take a sample of 3 employees. What's the probability exactly 1 will leave the company? Is 0.243. That's you already saw when I showed you tree diagram, and I also showed you the formula. If you're interested in finding out probability of not more than 2 employees leaving the company, then from 1 you subtract the probability of 3 employees leaving the company. So 1 minus 0.001, and you have the answer. So that's the nice thing about this table, that you can save time and you can just pick up the answer from there. The only issue over here is that what if probability of success is 0.17? Okay. the sample size, right? So let's say the tables I provided goes up to only 25, n is 25. So it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 15, and then 20, and 25. What if the sample size is 23? So that's the problem. Okay? So then you can use the formula. Now, so let's say you cannot use the table. So here is probability x is less than or equal to 11, n is equal to 23, p is equal to 0.10. You need to find out, you cannot use the table, tree diagram is going to be massive, you need a huge paper, plus size. Okay. So, what you should do? I mean, you can use formula, but 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. You have to use that formula 12 times. What can you do? Is there an easier way?
Can't you do the same thing with the first one?
Hmm?
Can't you do the same thing which is over the first one? So like, just find out.
That's small, right?
So find out the point where it's 12, or that would be.
So here either I should find out the probabilities for 0 to 11, or from 1 I subtract probability of 12 to 26. Okay?
It's too much.
It's too much work. What can you do? Binomial distribution, you just saw that it has a mean and a standard deviation. You saw that? Okay. Mean is NP, standard deviation is NP1 minus P square root. Can you tell me how each normal distribution is defined? You'll see that. Each normal distribution is defined by its mean and standard deviation. So what you can do is, you can approximate binomial normal. And answer is very simple, very quick. We'll see that. So I'm doing the things from multiple chapters at the same time, okay? Now this. Now, another distribution. So in our case, we are just going to be concentrating on binomial, okay? Pasa or fish distribution. Okay. Now what is that? It is used when we are looking at, let's say, in 2 kilometers of highway. In 2 kilometers of highway, how many potholes are there? Or in half an hour, how many ambulances arrive at the hospital? So let's the question could be like this. On average, 3 ambulances arrive each 1 hour at the hospital. What's the probability that in the next 1 hour, 2 ambulances will arrive? So Poisson distribution is used when we're looking at time or distance. When we're looking at time or distance, okay, so these many ambulances arrive in 1 hour, or these many potholes in a highway, okay. And here is a formula to solve for Poisson probabilities. Like any distribution, Poisson distribution also has a mean and standard deviation. In case of Poisson distribution, mean is equal to variance, okay? And of course, standard deviation is simply the square root of variance. Now, hypergeometric distribution, if you recall, I mentioned it to you. Hypergeometric distribution is just like binomial. The only thing is, in case of hypergeometric distribution, probability of success is changing. You saw this over here. This is hypergeometric distribution. Probability of success is going down. at, the notes are very detailed, so you can read that yourself. Okay, I have to move forward. Now let's look at the next one. So in countries distribution, we are only going to be concentrating on normal. Why is that? I mean, what's the reasoning for that? I mean, there could be all kind of countries distribution. Why we are just going to pay attention to normal? A distribution could be of any shape. A distribution could be of any shape, but
Don't we assume it's normal if it's above a certain sample size?
a distribution could be of, thanks a lot, okay? A distribution could be of any shape. Okay? It could be rectangular. It could be triangular. It could be skewed to the right. It could be skewed to the left. It could be of any shape. But if you take a sample, so let's say if I take a sample from this distribution, if I take a sample from this distribution, let's say sample is of size 30. I took a sample of 30 from this distribution. This sampling distribution will be approximately normal. And that is called central limit theorem, which is going to be coming on later on. What central limit theorem says, your distribution could be of any shape. But if you keep increasing sample size, sampling distribution will keep coming closer and closer to normal distribution. Your distribution could be of any shape, but if you keep increasing your sample size, your sampling distribution will keep coming closer and closer to normal distribution. As a rule of thumb, if your sample size is at least 30, you can assume that your distribution is normal. So let's see. Oh. Just playing games with us. Uniform distribution, normal distribution, exponential distribution. You can look at these yourself. Okay, I'm just going to be looking at normal distribution. The normal probability distribution is the most important distribution for describing continuous random variable. It is widely used in statistical inference. It has been used in a wide variety of applications: height of people, test scores, amount of rainfall, scientific measurements, rates of returns. You have collected data. You have collected data on a certain mutual fund. And you found that this well-diversified mutual fund, on average, during the last 10 years, gave a return of 15% with a standard deviation of 5%. Gave a return of 15% with a standard deviation of 5%. You can answer, or you can ask many different questions. What if I invest for 1 year? What is the probability that I'll earn at least 20%? So I'm looking at something over here like this. So here is a normal distribution. Mutual fund returns. On average, it gave a return of 15%. Standard deviation is 5%. I like to find out if I invest. So when you look at this, when you look at the past, okay, you found that on average it gave a return of 15% with standard deviation of 5%. I like to find out what is the probability that if I invest in this fund, in 1 year, I'll be earning at least 20%? At least 20%. So, that's what I'm trying to solve for. Now, here is normal density function. Okay, now, before I go into that, I mean, here I'm just telling you what the normal distribution is symmetric. Okay, and over here, it is at the center over here. Can you tell me what is below the peak? What is over here? Exactly under the peak. Mean, median, and mode. Okay, all three are over there. So these are all different normal distributions. Okay, over here you have a distribution with a mean of -10. Here is 0. Here is 25. And here are, I mean, you have two normal distributions with the same mean, but different standard deviation. So what you see over here is each normal distribution can be defined by its mean and standard deviation. So over here, I mean, as far as dispersion is concerned, is the same. It looks the same, okay? Same spread, but the means are different. So, which means they are different distributions. So -10 is the mean with the same standard deviation. 0 is the mean with the same standard deviation. 25 is the mean with the same standard deviation. Over here, I'm telling you, look, guys, even if the mean is same, it doesn't mean that distribution are same. Well, this distribution over here is more spread out, and this distribution over here is less spread out. Suppose over here underneath I have 20. Suppose under here I have 20. So I have a question. Like, you are a manufacturing company, you place an order for raw material, and sometimes it takes 8 days, sometimes it takes 10 days, sometimes it takes 15 days, sometimes it takes a month. So from the time you order till the time you receive is called lead time. And they are different, okay? 8, 10, 15, 20, okay? You figure out that on average, it takes 12 days. On average, it takes 12 days. If you place an order when you have 12 days of inventory, what is the probability that you will run out before the raw material arrives? What's the answer? You don't need any calculation. Lead time, the time when you placed an order and got the raw material, it could be 8 days, 10 days, 11 days, 15 days, 20 days, but on average it's 12 days. On average it is 12 days. If you place an order when you have enough raw material for 12 days, what's the probability that you will run out of raw material before raw material arrives?
100%.
What? 0? We are talking about normal distribution. Where the average falls, average is over here. So what's the probability that you will run out of raw material before the raw material arrives? If you just have enough inventory for 12 days. So, sorry, if you just have enough inventory for 12 days, yeah. What's the answer?
50%.
50%. So if you just keep enough inventory for the average number of days, it is only 50%. That inventory will only be enough for 50 days. Sorry, 50%, and only be enough for 50% of the times. 50% 50% time you'll be short. If I want to be 95% confident that I have enough inventory, I have enough raw material, then how much like, where should I be falling? For how many days of inventory I should be having?
Just standard deviations of it from both.
Oh, it should be over here, right? It should be something over here, right? So this should be 95%. If you want, like on average, it takes 12 days to get raw material. Sometimes it will take more, sometimes it will take less. But if you want to be 95% sure that you have enough raw material, then you should be planning for much more than 12 months. How much more we'll calculate that. Because if you plan for only 12, then it is only 50% time you have enough raw material. I mean, here is some values which we just picked from the table, okay? So 68.26% of the values of normal random variable are within one standard deviation mean, and 95.44% within 2 standard deviation, 99.72% within 3 standard deviation. 100% of the values are within how many standard deviations? 100% of the values are within how many standard deviations?
3.
I mean, it's over here, right? 3, 99.72. I'm saying 100%.
There's no, it's not a standard deviation.
It is going to go to negative infinity, positive infinity. Doesn't make any sense. I mean, normal distribution, when you look over here, I hope. I mean, if you look with magnifying glass, you will say this curve comes closer to the base but never touches the base. So it goes negative infinity to positive infinity. If you want to be 100% confident, then it is going to be negative to positive infinity. Doesn't make any sense. Okay? So instead of going to 100%, we go to 99.72 and we assume it to be almost 100%. Now, so let's say this is not this here. No. Bad shape. They are all normal distributions with different means and standard deviations. So over here, mean is equal to, let's say, 20, standard deviation is equal to 15. Mean is equal to 21, standard deviation is equal to 10. Mean is equal to, let's say, 23, standard deviation is equal to 9. So there are 3 normal distributions and with different means and standard deviation. Each normal distribution is defined by its mean and standard deviation. But we can do a conversion to these, and that conversion will give us a standard normal distribution. Each of this will become then same. Now, a standard normal distribution. Or Z distribution. Z distribution. How do you get that? You have these normal distributions. You can have infinite normal distributions. But when you convert them to standard normal distribution, they all look alike. They all are exactly the same. Can you tell me what is the mean of Z distribution and what is the standard deviation of Z distribution?
The mean is 1.
Mean, mean, standard deviation of Z distribution? All these three, in terms of Z distribution, will be having the same mean and same standard deviation, which is 0 and 1. Mean will be 0 and the standard deviation is going to be equal to 1. Now, the benefit of this is that by doing this conversion, we can answer many questions. We can answer many questions. So for example, what's the probability of earning at least 90%? Within what range? Within what range 80% of time my returns are going to fall? So we can answer all those kind of questions, okay, once we do the conversion to Z distribution. Okay. So here is your Z distribution with mean of 0 and standard deviation of 1. Okay. That's how you do the conversion. PEP zone sells auto parts and suppliers, including a popular multi-grade motor oil. When the stock of this oil drops to 20 gallons, a replenishment order is placed. The store manager is concerned that sales are being lost due to stockouts while waiting for a replenishment order. So you are placing order when the stock drops to 20 gallons. It has been determined that demand during replenishment lead time is normally distributed with a mean of 15 gallons and a standard deviation of 6 gallons. If you place an order when you have 15 gallons in inventory, what's the probability of stock out? Guys, I asked you this thing many times before, just now. What's the answer? And you don't need any calculation. What's the answer? 50%. It has been determined that demand during replenishment lead time is normally distributed mean of 15 gallons. Mean in normal distribution is exactly in the center. 50% is below, 50% is above, okay? The manager would like to know the probability of stock out during replenishment lead time. Now, they are placing an order when they have 20 gallons. In other words, what is the probability that demand during lead time will exceed 20 gallons? So they will have a stock out if the demand is more than 20 gallons. So this is your X distribution. Mean is equal to 15. You like to find out probability over here. You like to find out what's the probability the demand during lead time is going to be more than 20 gallons. Now, what you do is you convert into Z distribution. Okay. So, probability X is greater than equal to greater than 20. X is 20. Standard deviation is about 6. So if you're looking in terms of picture, it is like this. Z distribution has a mean of 0, and you're looking over here. This is your Z distribution. This is your X distribution, distribution of X, okay? Oil, gallons of oil, and over here is your Z distribution. I always find it helpful to draw a picture, okay? So here is normal probability distribution table, okay, and what you do, we are trying to locate 0.83. So you have this column, 0.8, and this is 0.03, so 0.83. Now, when you look over here, 0.7967, which probability is this? In this chart, which area it covers?
All of them, from the line all the way to that.
In this one?
Yes.
Thanks a lot. Okay. So it is cumulative probability. It gives you all the area up to 0.83. So on this. But I'm interested in this. This whole thing is 100%. So for 100%, you take out 0.83. So the answer is 0.7967. And what is that? I think it's on the next page. 0.2033. Guys, this is a attendance list. I'm just passing it on. Please sign it and keep passing it on. Just look at your name, sign it and keep passing it on. Go row by row. You guys are okay? Now, so the demand during lead time is 15 gallons, which means sometimes less, sometimes what this is for. Oh, I'm sorry. That's why I was wondering, okay, why did you pass it on so quickly? I have everything ready. And we have both over here, okay? So here is a nicer one for you. 3 pages. So we just submerge the probability to stock out. But we could be interested in another question. So let's look at the other question. In the manager of that zone, wants the probability of stock out during the replenishment lead time to be no more than 0.05. Or I can also say they want to have enough inventory to meet the demand 95% of the time. So they are looking at stock out only 5% of the time. What should be the reorder point? Now over here, it will be something like this. Can you tell me how much area is over here? On the graph, how much area should be over here? 5.95. Perfect. So you need to find an x value over here. You need to find an x value below which you have 95% of the area. Now, in terms of z value, you need to find out z value below which you have 95% of the area. that's the chart over here. You can see 95% of the area is below Z value. Now, when I look at the table, and those tables will provide it to you. So inside you have probabilities, and over here column headings and row, they will give you Z value. So let's say this is this 1.5, 0.00, so Z value is 1.5, probability is 0.9332. Can you tell me what this probability is? Is it the probability of Z value exactly 1.5? Yes.
Well, with the table you're showing us, it's just how much area. So if we went to Z value 1.5, for example, what percentage of the area is before that?
Thanks, sir. This is the area which is not exactly falling on 1.5. It is the area up to 1.5. It's cumulative. Tell me, what is the probability that the demand during lead time is going to be 20 gallons? What's the answer? Demand during lead time is going to be 20 gallons. Exact 20 gallons. What's the answer? Answer is 0. In a continuous distribution, you have infinite outcomes. Total probability is 1. So 1 divided by all the infinite outcomes, what's the answer? So probability for any exact value in a continuous distribution is 0. So that's why we look at cumulative, or we look at the ranges, okay? So over here, this Z value, I need to find a Z value below which 95% of the area is, okay? Now, so I'm looking over here trying to locate 95% of the area. These are cumulative probabilities, okay? Now, I don't see 95%, I see 0.9495, 0.9505. What you can do is, and this is 1.64, and this is 1.65. You just take the average of these two. So 1.645. You guys are okay with that? Now, so the attendance list is fine. Now you can find your names. See the magic? Within seconds. Okay. And you have the list which has names. Okay. Z is equal to x minus mu plus standard deviation. I am solving it. I am solving it for x. So x is equal to mu. Now of course Z value could be plus or minus. Z value could be plus or minus. If it is minus, you put minus sign over here. If it is plus, you put plus sign over here. Now in this case, see over here is 0. Z value over here is going plus or minus. Z value over here is going plus or minus. Minus, okay. If you are below 0 is minus, if you are above 0 is plus. So x is equal to mu plus z square deviation. Solving for that, 15 is the mean. Okay, and we already found 1.645 z, and 6 is the standard deviation. So the answer is 24.6. So if you want probability to stock out to be not more than 5%, you should be having 24.87 gallon inventory. If you have 25 gallons, then the probability of stock out is slightly less than 5%. You guys are okay with that? You can read exponential distribution yourself. Okay. So we are done with this. We finished 2 chapters. Can you believe that? In your BBA, okay, you are finishing 1 chapter in 3 weeks. So we are going to take a 10 minutes break. Then we'll do the remaining 3 chapters. Now guys, I have office hours. I know that things are moving very fast, okay? And you might have taken these stats a while ago. Yesterday there were quite a few students who came to see me, okay? That was very nice of you. I really appreciate it, okay? So please come and see me. And if you need more office hours, I'll be having more office hours.